We're going to continue talking about chemical bonding, and in this video we're going to start talking about Lewis diagrams. There will be several videos on Lewis diagrams. Now, there are two types of chemical formulae. The first one that you are familiar with is the molecular formula. The molecular formula is simply the inventory of all the elements in a compound. For example, C2H6O is the molecular formula. It tells you what's in the compound, but not how it is structured. To know how it's structured, you need the structural formula, because that shows you the structure. C2H6O could be this compound. This compound is dimethyl ether, but it could also be this compound, which is ethanol. Different compounds, different chemical and physical properties. When a molecular formula has more than one structural formula, we call those structural formulas isomers of each other. And the drawings of the structural formula are called Lewis diagrams. Now, there are 5 steps to drawing a Lewis diagram. The first step is to fill out an NASB table. And before you ask what an NASB table is, I will explain. The N stands for the number of valence electrons an element needs to have a noble gas configuration. Remember the octet rule. N equals 2 for hydrogen. If the element isn't hydrogen, then the N equals 8. The A is the actual number of valence electrons that an element has available. The S is the number of electrons that need to be shared so that the elements can achieve noble gas configuration, and S is actually to the total number N minus the total of A. And because each line of a bond represents 2 electrons, the number of lines that will need to be drawn, or the number of bonds needed, is equal to S divided by 2. So let's do an example. Phosphorus trichloride. We set up the box, element, the N, the A, the S, the B. We start with phosphorus. We have 1 phosphorus. Each phosphorus needs 8 electrons to reach noble gas configuration. 1 times 8 is 8. Each phosphorus has 5 valence electrons. 1 times 5 is 5. Then there's the chlorine. We have 3 chlorines. Each chlorine needs 8 electrons to reach noble gas configuration. 3 times 8 is 24. Each chlorine has 7 valence electrons. 3 times 7 is 21. Now we total up the N column and the A column. So we need 32 electrons, but we only have 26 electrons. However, 32 minus 26 happens to equal 6, so we need to share 6 electrons. 6 divided by 2, because each line has 2 electrons, means that we need to draw 3 lines, or 3 bonds. Step 2, determine the central atom, the atom that everything else will be bonded to. If carbon is present, it will be the central atom. If carbon is not present, it will be the least electronegative atom. How do we know the electronegativity? You don't need to know the absolute value, you just need to know where it lies on the periodic table. Now remember, fluorine is the most electronegative element, and francium is the least electronegative. So, as you go from right to left, the electronegativity decreases. As you go top to bottom, the electronegativity decreases. Hydrogen is never the central atom. So once again, let's take a look at the phosphorus trichloride. We look at the periodic table. Here's phosphorus, here's chlorine. Phosphorus is obviously to the left of the chlorine, so phosphorus is less electronegative than the chlorine. So in this compound, the phosphorus is the central atom. Now you're going to write down the central atom and place the other element or elements around the central atom, putting atoms into the quadrants as appropriate. So it'll look something like this. We only have to fill up 3 of the quadrants because we only have 3 outer elements. The next thing you're going to do is draw a single bond between the central atom and the outside atoms. So it looks like this. But remember, each line equals 2 electrons, and what we're doing is taking our available electrons and placing them into the compound. So now we need to subtract 2 electrons from the available column for each bond drawn. So if you remember, we had 26 available electrons. We've now used 6 of them up for for bonds here. 3 times 2 is 6. So we still have 20 electrons that we need to place into the diagram, which brings us to step 5. Distribute the remaining electrons in pairs around the elements so that complete octets are formed. So in this case, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. When you do that, all of the electrons have now been placed. We've used up all 26. So now you can see that this chlorine has 8 valence electrons. This has 8 valence electrons. This has 8 valence electrons. And this has 8 valence electrons. The octet rule has been satisfied. This is a valid drawing. So under the guise of see one, do one, here is bromomethane, or CH3Br. Please draw out the Lewis diagram for this. Come back, check your work, and we'll walk you through it. Go. And there's the correct drawing. How did we get it? The first thing we did was fill out the table. So we set it up. 1 carbon. Once again, N equals 8 for all elements except for hydrogen, so 1 times 8 is 8. 4 valence electrons, 1 times 4 is 4. 3 hydrogens. The N for hydrogen is 2. There are 3 hydrogens, so 3 times 2 is 6. Each hydrogen has 1 valence electron, so 3 times 1 is 3. 1 bromine. It's not hydrogen, so 1 times 8 is 8. It has 7 valence electrons. 1 times 7 is 7. Total the things up. We need 22 electrons. We have 14 electrons. 22 minus 14 is 8. 8 divided by 2 is 4. So now we can go on to step 2. Determine the central atom. Well, bromomethane has a carbon. So the carbon is the central atom. So now we're going to write down the central atom and place the other elements around it. And as long as you have 3 hydrogens and 1 bromine, any setup is fine. We're going to draw the single bonds between the central atom and the outside atoms. Each bond has 2 electrons, so we're going to take away 2. We have 6 electrons to place. We know that hydrogen cannot take on any more electrons, so we're going to distribute it to the bromine, 2, 4, 6. We've now used up all of our electrons. This hydrogen, and this hydrogen all have 2 electrons. That gives them a noble gas configuration. The carbon here has 8 electrons, noble gas configuration. And the bromine, noble gas configuration. The conditions are all met. This was a valid structure. So to review, Lewis diagrams are a method of showing the structure of a molecule. Lewis diagrams are a 2D depiction of 3D structures. A little warning, we will soon be talking about the 3D structure of molecules. The reason being, the 3D structure explains many physical properties, and in chemistry, function follows form. There are 5 steps. If you follow the 5 steps, you should come to a correct drawing, because there may be more than one correct drawing. Fill out the table. Figure out the central atom. Write down the central atom and place the other elements around it. Draw a single bond between the central atom and the outside atoms. Then distribute the remaining electrons to complete the octets, and you're done. So this is the initial introduction to Lewis diagrams. We're not finished with them. We still haven't talked about double or triple bonds, but the next video will deal with those topics.